Every day, we use communication systems like radio, television, mobile phones, and the internet. In all of these systems, information such as voice or data is sent from a transmitter to a receiver. Instead of sending the message directly, we first place it onto a high-frequency signal called a carrier. This process is called modulation. At the receiver, we must remove the carrier and recover the original information. This process is called demodulation. In this video, we will explain what demodulation is, why it is needed, and how it works for both analog and digital communication systems. Why demodulation is needed. A message signal, like a voice signal, has a low frequency and cannot travel efficiently over long distances. It is also difficult to share the channel with many other signals. So, we combine the message with a high-frequency carrier using modulation. The modulated signal can now travel far and be transmitted efficiently. However, the receiver does not want the carrier. It only wants the original message. So, the receiver uses a demodulator to extract the message from the received signal. In simple words, modulation puts the message onto the carrier, and demodulation takes the message back off the carrier. Basic communication system. A basic communication system works like this. First, we have the message signal. Then, the message goes into a modulator and is combined with a carrier. The modulated signal travels through the channel and may pick up noise. At the receiver, the demodulator processes this signal. Finally, the original message is recovered. So, demodulation is a key part of every receiver. Analog demodulation. Let us start with analog communication. Common analog modulation types are AM, FM, and PM. AM demodulation. AM stands for amplitude modulation. In AM, the amplitude of the carrier changes according to the message signal. To demodulate an AM signal, we can use an envelope detector. This circuit follows the outer shape, or envelope, of the AM waveform. That envelope is the original message signal. So, AM demodulation is done by detecting changes in amplitude and recovering the message from the envelope. FM demodulation. FM stands for frequency modulation. In FM, the amplitude stays constant, but the frequency changes according to the message signal. To demodulate an FM signal, the receiver must detect these frequency changes and convert them back into the message signal. One common method uses a phase-locked loop, or PLL. The PLL tracks the frequency of the incoming signal, and its output follows the original message. So, FM demodulation is based on measuring frequency changes and converting them back into the message signal. PM demodulation. PM stands for phase modulation. In PM, the information is carried in the phase of the carrier signal. To demodulate a PM signal, the receiver detects how the phase of the signal changes compared to a reference signal. This is often done using a phase detector or a PLL. So, PM demodulation is based on tracking phase changes and recovering the original message. Digital demodulation. In digital communication, the message is a sequence of bits, like ones and zeros. These bits are sent by changing the amplitude, frequency, or phase of the carrier. At the receiver, the demodulator measures the received signal and decides which bits were sent. In amplitude shift keying, or ASK, the receiver measures the amplitude and decides whether a 0 or a 1 was sent. In frequency shift keying, or FSK, the receiver detects which frequency is present and maps it to the correct bit. In phase shift keying, or PSK, the receiver compares the phase of the received signal to a reference and decides which symbol was sent. In quadrature amplitude modulation, or QAM, both amplitude and phase are used. The receiver measures both and chooses the closest point from a set of known symbols, often shown on a constellation diagram. In simple terms, digital demodulation is based on measuring, comparing, and deciding. Conclusion. Demodulation is the process of recovering the original message signal from a modulated carrier. For AM, we detect amplitude changes. For FM, we detect frequency changes. For PM, we detect phase changes. For digital systems, we measure the signal and decide which bits were sent. Demodulation is a vital part of all modern communication systems, including radio, television, mobile phones, and wireless networks. Without demodulation, we would not be able to receive or understand any transmitted information.